The impact of cloud computing on industry and end users will be difficult to overstate, as many aspects of everyday life have indeed been transformed by the omnipresence of software that runs on cloud networks. By leveraging cloud computing, startups and businesses are able to optimize cost and increase their offerings without purchasing and managing the hardware and software themselves. Good people, despite the growing presence of cloud computing, its details remain not clear to many of us. What exactly is the cloud? How does one use it? What are the benefits for businesses, that's developers, researchers, government, healthcare practitioners, and students? As part of my series, in this video, we will provide a general overview of cloud computing, its delivery models, offerings, and risk. You will gain an understanding of how the cloud can help support business, research, and education. Good people, to remind you, this is the 10th video in my series where I'm teaching about internet and web fundamentals. In the last video, we looked at what is needed to connect to the internet and common methods of internet connection. In today's video, what exactly is cloud computing? In a nutshell, cloud computing is the delivery of computing resources as a service, meaning that the resources are owned and managed by the cloud provider rather than the end user. Those resources may include anything from browser-based applications such as Netflix, third-party data, storage for photos, and other digital medias such as the iCloud or Dropbox, or third-party servers used to support the computing infrastructure of a business, research, or other personal project. Guys, before broad proliferation of cloud computing, businesses and general computer users typically had to buy and maintain the software and hardware that they wished to use. With the growing availability of cloud-based applications, storage services, and machines, businesses and other consumers now have access to wealth of on-demand computing resources as internet-accessed services. Then, shifting from on-premise software and hardware to networked, remote, and distributed resources means that cloud users no longer have to invest the labor, capital, or expertise required for buying and maintaining these computing resources by themselves. This unprecedented access to the computing resources has given rise to new waves of cloud-based businesses, changed IT practices across all industries, and transformed many everyday computer-assisted practices. All this said, the following are essential characteristics of cloud computing. Essential characteristic number 1 is on-demand self-service. Cloud resources can be accessed or provisioned without human interaction. Note that. With this model, consumers can gain immediate access to cloud services upon a sign-up. Organizations can also create mechanisms for allowing their employees, customers, or partners to access internal cloud services on demand according to predetermined logics without needing to go to or to go through IT services. Number 2, broad network access. Users can access cloud provide services and resources through any device and in any networked location, provided they have permission. Essential characteristic number 3, resource pooling. Here, cloud provider resources are shared by multiple tenants while keeping the data of individual clients hidden from other clients. Essential characteristic number 4 is rapid elasticity. Unlike on-premise hardware and software, cloud computing resources can be rapidly increased, decreased, or otherwise modified based on the cloud users' changing needs. Then the last essential characteristic is measured service. Usage of cloud resources is metered so that businesses and other cloud users need only to pay for the resources they use in any given billing cycle. Good people, cloud resources are provided in a variety of different delivery models that offer customers different level of support and flexibility. Delivery model number 1 is what we term infrastructure as a service. This is the on-demand delivery of computing infrastructures, including operating systems, networking, storage, and other infrastructural components, acting much like a virtual equivalent to physical servers. It relieves cloud users of the need to buy and maintain physical servers, while also providing the flexibility to scale and pay for resources as needed. It's a popular option for businesses that wish to leverage the advantages of the cloud and have system administrators who can oversee the installation, configuration, and management of operating systems, development tools, and other underlying infrastructures that they wish to use. Given its flexibility, infrastructure as a service can support everything from companies' computing infrastructure to web hosting to big data analysis. Number 2 is platform as a service, PaaS. Platform as a service provides a computing platform where the underlying infrastructure, such as the operating systems and other software, is installed, configured, and maintained by the cloud provider, allowing users to focus their efforts on developing and deploying apps in a tested and standardized environment. This is commonly used by software developers and other developer teams, as it cuts down on the flexibility of setting up and maintaining computer infrastructure, while also supporting collaboration among distributed teams. Platform as a service can be a good choice for developers who don't have the need to customize their underlying infrastructure, or those who want to focus their attention on development rather than DevOps and systems administrator. Number 3 is software as a service, that SaaS. Software as a service providers are cloud-based applications that users access on demand from the internet without needing to install or maintain the software. Example includes GitHub, Google Docs, Slack, and Adobe Creative Cloud. Software as a service applications are popular among businesses and several users, given that they are often easy to adopt, accessible from any device, and have free, premium, and enterprise versions of the application. Like platform as a service, it abstracts away the underlying infrastructure of the software application so that users are only exposed to the interface they can interact with. What are the cloud environments? Cloud services are available as public, private resources, each of which serves different needs. So, what are the public cloud? The public cloud refers to the cloud service such as virtual machines, storage, or application, offered publicly by a commercial provider to businesses and individuals. Public cloud resources are hosted on the commercial providers' hardwares, which users access through the internet. Guys, they are not always suitable for organization in highly regulated industries such as healthcare or finance, as public environments may not comply with industry regulations regarding customer data. Then, private cloud refers to the cloud services that are owned and managed by the organization that uses them and available only to the organization's employees and customers. Private clouds allow organizations to exert greater control over their computing environment and their stored data, which can be necessary for organizations in highly regulated industries. Private clouds are sometimes seen as more secure than public clouds, as they are accessed through private networks and enable the organization to directly oversee their cloud security. Public cloud providers sometimes provide their services as applications that can be installed on private clouds, allowing organizations to keep the infrastructures and data on premise while taking advantage of the public cloud's latest environments. Then the last environment is hybrid and multi-cloud. Many organizations use a hybrid cloud environments which combine public and private cloud resources to support the organization's computing needs while maintaining compliance with industry regulation. Multi-cloud environments are also common, which entail the use of more than one public cloud providers. For example, combining Amazon Web Services and DigitalOcean. The following are benefits of cloud computing. Cloud computing, as we have seen, offers a variety of benefits to individuals, businesses, developers, and other organizations. Guys, these benefits vary according to the cloud user's goals and activities. I will begin with business and industries. Prior to the proliferation of cloud computing, most businesses and organizations needed to purchase and maintain the software and hardware that supported their computing activities. As cloud computing resources became available, many businesses began using them to store data, provide enterprise software, and deploy online products and services. Some of these cloud-based adoptions and innovation are industry-specific. In healthcare, many providers use cloud services that are specifically designed to store and share patient data or communicate with patients. In academia, educators and researchers use cloud-based teaching research apps, but there are also a large number of general cloud-based tools that have been adopted across industries, such as apps for productivity, messaging, expense management, video conferencing, project management, newsletters, surveys, customer relations management, identity management, and scheduling. The rapid growth of cloud-based business apps and infrastructure show that cloud is not just changing business IT strategy, it's a booming business in its own right. Then for developers, computing resources that were once only affordable to large companies and organizations are now available on demand through an internet connection and at a fraction of their previous cost. In effect, independent developers can rapidly deploy and experiment with cloud-based apps. Cloud-based apps for sharing codes such as GitHub have also made it easier for developers to build upon and collaborate an open source software project. Additionally, cloud-based educational platforms and interactive coding tutorials have expanded access to developer education, enabling individuals without formal technical training to learn to code in their own. Then for the researchers, as machine learning methods become increasingly important in scientific research, cloud computing has become essential to many scientific fields, including astronomy, physics, genomics, and artificial intelligence. The massive amount of data collected and analyzed in the machine learning and other data-intensive research projects often require cloud computing resources that scale beyond the capacity of hardware owned by an individual researcher or provisioned by the university. Cloud computing allows the researchers to access computing resources such as their workloads requires and allows for real-time collaboration with the research partners across the globe. Without commercial cloud providers, a majority of academic machine learning research will be limited to individuals with access to university provisioned high-powered computing resources. Then for educators and students, guys, you can be able to see that cloud computing has also provided students with tools for supplementing their education and opportunities to put their technical skills into practice as they learn. Cloud-based apps for sharing, teaching, collaborating on code and data such as GitHub enable students to learn technical skills in a hands-on manner by studying, deploying, and contributing to open source software and research projects relevant to their field or professional aspiration. And just like independent developers, students are able to use cloud computing resources to share their codes and apps without the public and reap the satisfactions of underlying the real-world application of their skills. Good people, though the cloud offers many benefits, it also comes with its own set of risks, cost, and ethical questions that should be considered. Some of these issues are relevant to all cloud users, while others are more applicable to businesses and organizations that use the cloud to store customers' data. The following are considerations for all cloud users. Point number 1 is security. Cloud resources can have additional security vulnerabilities compared to traditional on-premise data centers, given their use of APIs, cloud-based credentials, and on-demand services that make it easier for attackers to obtain unauthorized access. Find out what measures the cloud provider service takes to secure customer data from theft and other attacks, and what are practices or additional services customers can implement to safeguard their personal data. Number 2 is data loss. Just with the physical owned or managed devices, cloud services can permanently lose stored data due to physical disaster, bugs, unattended syncing, user-generated errors, or other unforeseen issues. When implementing cloud services, find out what backup service the provider offers to be aware that this may not be automatically or fully provided. You may also choose to run backups yourself. Consideration number 3, data persistence. There are times when cloud users may want to ensure the deletion of personal data they have given to cloud service provider. However, the processes for deleting data on cloud resources and verifying that deletion can be time-consuming, complicated, or even impossible. Before you give cloud providers access to your data, find out what their policies for deleting it in case you want to remove the data completely. Point number 4, cost. Though the cloud can provide computing services at a fraction of the cost of owning them, expenses for cloud services can quickly ramp up with usage. When signing up for a cloud service, check the billing details to learn how services are metered and whether you can set caps or notification when usage goes beyond your desired limit. It also worth researching how billing details are communicated, as the billing methods of some providers are not always easy to understand. Point number 5, company use of data. Cloud service providers may use data to understand customer use of their product, sell or personalize ads, train machine learning algorithms, or even sell customers' data to outside entities. If you have concerns about how your organization's data is used, make sure to find out the service provider's policies regarding to their use of it. Then the last point is loss of user control and visibility. The use of third-party computing resources makes it difficult or impossible for cloud users to have full visibility and control over their computing environments, which can create a variety of technical and trust concerns. Some of these technical concerns can be helped through the use of monitoring and analytic tools, which allow users to stay updated on their infrastructure's performance, allowing users to respond quickly when problems arise. Trust concerns, such as those related to a company's use of personal data, can be addressed by reviewing the company's customer data policies and public forms of analysis about its data practice. Good people, in conclusion, cloud technologies offer a variety of opportunities to businesses, independent developers, researchers, educators, and students. By understanding the difference between models, benefits, and risk offered by the cloud, users can make informed decisions about how to best take advantage of its offering. Good people, thank you so much for watching to this end. In the next video, I will be talking more about search engine example and how does it work. See you in the next video.